Hello everyone, good morning, good afternoon, good evening. Thanks for watching Coffee and Cloud with Navneet. So in today's session, we are going to learn how you can optimize your Glue performance for JDBC connections. So those who do not know AWS Glue is an ETL tool which allow you to bring the data from different data sources and allow you to perform all kind of a transformation, right? And then let you store the data in your different data stores, whether it's a databases, data warehouse, or data lake. So usually I have seen like people using AWS Glue to bring the data from the databases. And in this session, we are going to learn how you can enable parallelism. When you're working with your database with the Glue to kind of optimize in terms of performance. So what we're looking to do is firstly understand the architecture, like okay, what the solution is all about, and then we're going to go and learn about actual solutions, right? So let's get started. So this is again the simple architecture. Here what I'm doing is I have a SQL server where I'm looking to bring the data by using the glue, and then I'm looking to store the data into S3, right? But before bringing the data into SQL Server, what I did is I have created a JDBC connection, and by using the JDBC connection, I have crawled the MS SQL database. It's just more like I have extracted the metadata of SQL Server, and that metadata is being stored in a Glue data catalog. Thereafter, I have used Glue Studio job to build the pipeline, right? So Glue Studio is the new feature being added within the Glue, which allow you to make a visual UI or visual ETL pipeline, right? So where you're able to define source, destination, or any kind of a transform in between. And then I'm storing the data as in Parquet in S3, right? So so let's get started, right? So in this solutions, what we're going to learn is, so when we first start, we'll just go with the default configuration. I will talk about all the settings in default configuration. Thereafter, we're going to enable the auto scaling, which is again a new feature in AWS Glue, which allow you to define the maximum number of DPU, which is data processing unit, is a term being used in Glue, how they provide the compute, right? As it's in a service serverless, so you just have to define how much compute you need, and then Glue able to provide you that much compute. Thereafter, we are going to learn what all parallelism parameter which is available in a DynamicFrame. You must be wondering, like, what is DynamicFrame and why this is just means what all this parameter is all about. So we're going to learn all of them, and we talk about, right, what's the dynamic frame and data frame is, but we are not looking to go deep because here I'm just looking to cover how you can enable the parallelism by using this hash partition. But I will try to provide sufficient information for you to make a distinguish between the dynamic frame and your data frame. Okay, so let's get started. So what we're looking to do is default configuration and with no auto scaling, right? So in a default configuration, it has a 10 DPU and of course no auto scaling. So let me go back. Let me go to the AWS console and show you how the default configuration look like and how I have built that Glue ETL job. Okay, just give me 1 second. So we are here in AWS Glue Studio, right? And to save some time, I have already created multiple jobs, right? So first we are going with the default configuration, right? So what I'm doing is just, let's see how I have created the job, right? So I have this MS SQL server which I have already crawled and which is pointing to this table here, right? So if you go and look, like there are multiple tables being available, so I'm pointing to this table. Thereafter, just apply mapping, nothing special, I just kept it default. And thereafter we are just going and storing the data in our data lake, right? And data is being get stored into this S3 bucket, which I'm calling default. So let's see go the job details why I'm calling it default. So when I created this job, right, it comes by default with a 10 DPU. This is important parameter to remember. Okay, which is again right, this is a worker type G1X which we are using, and it has a 10 DPU, so it means it has a 10 executor in a way. I kept the retry 0 and this set this timeout 60, but again it's up to you how you want to do that. I just wanted to ensure if my job is failing, I will be, it should be get failed, right? So I have not to wait for three. Default is a 3 retry. Other very important thing which I did here is I have enabled the Spark UI, so I will able to go and look into that Spark history server, how my job has been executed, right? So what I will do is the first step is we'll go and run this job and see how much time it will taking to bring the data from MS SQL and uh, to from this table, right? And store into S3. So just to give you an idea here, on MS SQL, this table contain almost 57 million record, and and we're going to see, okay, how much time Glue with the 10 DPU take to bring 10 million record with the default configuration, right? So that's going to be an interesting right, kind of a if you have to think like, okay, how Glue performs, so it will give you some idea uh, in terms of like, okay, how Glue perform to bring the 57 million record. Just to let you know, like, this is primarily me having mm, having my databases up and running on EC2. So it may vary if you this time may vary if you have a database up and running on premises, right? Because all the network and everything as such. But it just give you a fair idea how much time it's supposed to take if you're running a Spark job to bring the data, that to be 57 million record, right? So if you look here, this is my um, SQL Server. This is my um, table, and it has like almost 57 million record, right? So let's go and run the job and see how the job is being performing. So I will go ahead and run the job. I will wait for this job to complete. Let me go and see when it started. Yeah, so it started. I will wait for this job to complete, and once this job will complete, we'll come back and review how much time it took to complete. Okay. So if you see here, the job is still running, right? It ran almost for 3 minutes 12 seconds, so and still showing running. So let's review like what's happening on the SQL Server side. So what I did, like, I just created this sample, it's just this query just uh, to review the log, and I see there are like, multiple processes is being opened. So if I just simply go and do a distinct and speed, right, and run this query and see how much. Okay, so if I just go and run this one here, okay, it's look like the, yeah. So this job is completed, look like, because I don't see any speed open. However, earlier I was able to see there was a multiple speed. So this is being, I think, is completed, but this look like it's still showing in running in here, just because maybe it's kind of shutting down the executor, right? So usually whenever we run the Spark, so it creates the Spark context, and then it could go ahead and once that is being job being completed, shut down. So it will take some time to start, and it will take some time to shut it down. Okay, so we're going to see how things look like in in Spark History Server and see if there are any. So if I go into Spark History Server, I just check, right? So this is what we have just ran, right? So if it today's date, and this is the application. So let's see. Let me go and see. So here, if you see, right, we have this total 10 executor, right? And this is like, okay, that's how much time job took to complete, right? So this is the job to complete, and this many executor is being added. So as I said, like, with the default, it has an added total 10. One is driver and 9 is worker, right? So this many executor is being added. So fair enough. I think we got an idea. So default, and it took like almost 4 minutes something second with if we just go with the Spark. Total and if you look here, right, we had a total 7 connection is being opened, and the reason being, right, if you're not defining any parallelism within your JDBC connection, so default parallelism is 7 for the JDBC from the for Glue and DynamicFrame. So this proves as well, right? Okay, if you're not defining anything, it will be opening a seven connections for you to bring the data from from your SQL Server or from your database, right? So that's nice. So we have kind of proved that point as well. So let me go and let go back and see what is happening here. So if I go back and see, yeah, so the job is completed. It took 4 minutes 48 seconds. And if I just go and so this is my S3. Let's see, going into this S3, we ran with the default, right? So let me see, where is the default? I think this is the default, right? So if you see here, this is like, it created 25 20 files, and yeah, so nice. So we got an idea, right? It taking that much of time, and then this is being running. So next, let me go back to my presentations to showcase like what we're looking to do next. So here we ran with the default configuration, and it has like almost 10 DPU and no auto scaling. The next we are looking to do enable the auto scaling. So what we're looking to do is we're keeping that we are changing the DPU from 10 to we are making it 40 DPU, right? So that's what we are assigning to our job. So let me go back to console one more time, and we'll show you how that look like. So here, let me go back to console and Glue Studio, right? So open the Glue Studio. Here is our second job with auto scaling. So this is my job for auto scaling, right? Let me go and see the property. So it will remain, everything will remain same. Bring the SQL from data from SQL Server to S3 bucket with no transform, just keeping everything same. Here what we're looking to do is, let me put this 40. So here we just changing and we enabling this auto scaling, and we are assigning 40. So this is the maximum DPU this job can allocate, right? It does not mean it's going to allocate all of them. It means if and when needed, it has that many DPU. So again, I kept everything same, just have that Spark UI enabled so we can get an idea how that is being performing, etc., right? So let's go back and see how that will look like. So save, yeah, as we have changed to 40 DPU, right? So I just save this job, and now let me go and run the job. So if I go and we'll wait for this job to complete as well. So when the job will running, right, there are one very nice thing about Glue is like you see this startup time. So this being drastically being reduced with Glue 3.0 earlier the startup time used to be in a minute, but now it's in seconds, right? So if you can think here, right, your glue job is being started, or your glue context being started within 17 seconds. So that's nice. That's kind of an improvement. When you run your job very first time, you will see like it will taking couple minutes, or sometime it take around a minute. But in a subsequent run, it will be way faster. Uh, I have seen like under 20 seconds being getting started. So yeah, let's go back and see what is happening in our database, and we can get an idea, right? So where is my database? Here is the database. So let's see if there's any. Okay, this is interesting. So I don't see any connection being open yet. We'll wait for connection to get open. Yeah, so see here, right, after, I don't know, maybe after 1 second I am able to see the connection with the database. So that is interesting. So if I see here, right, how many connections we have, so if I just go and do a distinct speed and run this query to get an idea. So just have to remove this one here. So we have this many here, 8, right? So let's see. Okay, we're going to go. If you see here, it's dividing with like how many connections which we have. So the default is 7. So again, it's opening the 7 connections that we know, and then this many record which we have. So it's just doing a cast against this. So it is doing the hash mapping here, right? So hash algorithm is being using to divide the data, and then like how much data they can each executor can bring in, right? So that's, it will giving the absolute number. So if I have to give you that number, if I will just run this query, let me simply just run this query. So it's been a while, I have not used no log, so that's, I don't know why no log is being working. I think this is why we have to use no log here. Yeah, but see, we got this result anyway. So I will try out like where I will Google it where to use no log. It's been a while. I have not used SQL Server. Let's see if that is working here. It's working, but I don't see much difference. Anyways, so we got an idea, right? It like kind of dividing this many of records. So this is almost like 8 million record. Yeah, so that makes sense because now we have a 57 million, right? So yeah, we have a 7 default, so it will be just creating, it will bringing all of one executor bringing that many record. So that makes sense. So let's see what's the status of the job, if the job is completed or it's not completed yet. So yeah, it's completed. But see here, that's interesting. So with an auto scaling, it took 5 minutes 52 seconds. Let's go and review the Spark history. What happened? Why, So we have this auto scaling, right? It took 5 minutes, and this just look here. It took 4.3 minutes here and 5.1 minutes here. So not much difference, but how many executors being added here? 1, 2, 3, total 6, right? Whereas when we were running our default configuration, it took like 10 executor. Here we have a 6. So in auto scaling, I have seen means now we have able to validate. Okay, even number of executors are less, and so maybe the glue job has determined, it generate multiple, so it has something called optimizer, so and which kind of optimize the execution plan. So it may have determined how it only need that many executor to process the data, so they don't don't need that much of executor. So see here, so we have total that this total 6 executor being allocated to run this job. However, it took extra time to complete it. So that's interesting. Okay, now let's go to the main concept. I think this is an important to to understand, because currently we just executed with auto scaling and default, so we have not added any parameter against it. So now we're going to go and enable the parallelism. So just keep in mind this all the options which I'm just talking here for the dynamic frame. It is not hold true for the data frame. So for the data frame, there are different parameters being available. You're easily able to find using in a Spark documentation. But for this video, I'm just keeping it to dynamic frame. Because when you work with the glue, most of the time you're working with the dynamic frame anyway, right? So dynamic frame, it has its own advantages over data frame. First of the biggest advantage is like it allow you to have do kind of resolve choice. So let's say if we have a data or column which has a different data type, like if you have a column where you have an integer, if you have a column where you have a string, you can say like, go with a choice, and then later you can resolve those choice. So that's where the dynamic frame has been very useful. Other is like, you have an option to enable bookmark against the dynamic frame, so it allow you to bring the incremental data, right? So that's nice. So other is here, right? So the first parameter is the hash partition, right? So just think of, right, when we were running our job, it had a 7 connection being open, right? Now this parameter, this partition parameter, will allow you to, or provide a knob to increase and decrease that number. I have seen cases where increasing the number, may end up having the bad performance, whereas decreasing the number may improve the performance. Similarly, right, I have seen cases where, when we're increasing the number, it improves the performance a lot, and when we're decreasing the number, it will be kind of, have a it has a bad impact. So it's totally depend like what kind of a query you run. It means what kind of a data set you have, and so you have to do some try means you have to try out some parameter before kind of finalizing, hey, this will be my best parameter for me to use, right? So let's learn, right, what's the example here. So in order for you to add those hash parameter, you have to use this additional options within your dynamic frame, right? So if you see here, right, we are using the dynamic frame, so creating dynamic frame from the catalog, which is fine, and then we are having this additional options with hash partition with the 5. You must be wondering like why I'm using the 5 now, why I have not increased the number. As I said earlier, right, we can try out and see how that is being performing. So I'm going with the small number first, and then we can go with the bigger number. Okay, so let's go and see how that is being performing. So let me go back to console. So where is my console? Okay, so we are here. So let me quickly. So we are here, and first thing we are looking to do is let's go to the job and see. So we are looking to job with the hash partition, right, and auto scaling. So I kept it, and just to let you know, it's a good idea to enable the auto scaling, right, because this way glue will determine how much executor it's required for you to run the job. For instance, like last time when we enabled auto scaling, though it took little like maybe 30-40 second extra, but in terms of saving cost, it helps in saving cost because that is run with a 6 executor instead of 10, right? So there is a cost saving. So you may wanna you wanna kind of keep it enabled, so this way it able to determine how much is being required. And also this is being, so I saved it, and let's go back and see the script, right? So here I'm running this with this additional option 5, uh, and as I went ahead and added the script, I just lose that visual, right? So hopefully Glue team able to come up where I'm not losing my visual, but for now, if you're going and editing your job, you will be losing the visual. So fair enough. Let's go ahead and run this with Hashpartition 5. Okay. So if I go and run it, so we are running with what we call auto scaling 40 worker node, and then we are having this Hashpartition 5, right? And I just executed the job, and we'll wait for it to start. So it started now. Let's go and see how the SQL Server look like. So as we have learned in the last time, right? It takes some time to even come up with all those nice speed IDs start showing. So as of now, I'm only able to see one speed ID. So, for last time it took almost a minute before it even listed all those speed ID. So yeah, so we'll wait for it to come. Let's go and see. So if you see here, right now we have 1, 2, 3, 4, 5, right? So we had Hashpartition 5. So earlier it used to generate 7, now we have 5. So it proved like, okay, how many connection is being opened against your database to bring the data. So let's see how that is being what's the SQL statement against it. So SQL statement is same like what we had earlier. So it's doing the hash partition or hash algorithm here, and then it dividing with the 5 number, and then we are getting, so it's like bringing somewhere almost like 10 point something, 10.7, right, million record. So and yeah, so because it's dividing like all this 57 million record by 5, so that many record is being kind of, but it's quite obvious, right? It's running with the 5, so just think of I'm just doing some time pass. So here the job is still running. It's almost 2 minutes 59 seconds. We'll see how much time it will take to complete this job with the 5 executor, and then we can run with the 10 executor, and we'll see. Or maybe we can just go with the 14 executor and see, because 7 is the default. So we try, let's go with number of, bringing more executor and see how that is being performing. So, oh my God, this select is still running. Sorry, this select count is still running. So that's really strange. Even with the no lock, it should be completing, but I don't know why it's taking so long to run. Yeah, so this almost like 11 million record, right? So each of them is kind of is executor is running. So yeah, so we'll see if it's completed or not. If it's still running, it's 4 minutes 3 seconds, right? So let's go to our Spark history and see what is happening there. So we have in the Spark history, we have, I don't see that is being completed, so not able to see in here. It may be that running job, right? So yeah, the last job which we ran with auto scaling, it took 5 minutes 1 second, right? but that is more on the Spark history side. Means in a Glue console, it might have more. Let me go and see. I don't remember that number. So it was auto scaling job took 5 minutes 52 seconds. Okay, so we'll see how this job is taking, how much time this job is taking to complete. So oh, so this is being done in 5 minutes 21 second. That's nice. So if I go back and look my Spark history server again, so if you see here, right, even with Hashpartition 5, it took more time as compared to when we had hash default, right? When means default Hashpartition is 7. So yeah, that we learn, with taking more time. So let's see here. This is the job, this is the timeline, this is, and again, this is interesting. See here, this how many executor, and that we have already we already checked on the database side. So that's nice. So we now know, like, okay, how that parameter works. So now second task is, okay, if I just go ahead and increase that parameter, or that how that's going to perform. So I'm going to make this 7 to 14, and let me save this one and run, right? So this is going to be interesting to see how this being performing with the 14. We learn, right, with the 5, it was better than the auto scaling default, but it was not better than another thing which we have learned is how many executor is being assigned to this job. Let's see, let that part. So yeah, it has a total 6 executor including your driver. So yeah, it has a 6 total 6 executor, right? So that is kind of again, right, similar what we had with an auto scaling, right, where it took 6 as well. So which is fine, means it definitely help us in saving some cost with a better performance than what we had with auto scaling earlier, right? So when we decrease that partition, so this get interesting, right? And okay, fair enough. So let me go back to my console and see how that is performing. So this job is still running. Let's go back and see on a SQL server, right? Where is the SQL server? So let me see and run and okay. So if you see here, right, this many supposed to be 14. I don't know why it's 15 here. So definitely one of the speed may not be from that executed. So let's see if I just ran. Let's do this one here. So if I just go with this one, let's see how this is. So this is a SQL server, and there was one, maybe something different, right? So you can get an idea here. Okay, yeah, this one is the speed ID. I don't know. This speed ID is not a part of 69. It's just because we have this SSMS open, so that's the speed ID. So yeah, technically it just only has a 14. So that's good, right? So we have this 14 here being running. So let's go and see this in here. It's showing speed ID, sorry, 59, not 55. If I just go and see, yeah, it is same. I don't see much difference. It's just having 14 divided by, so, like, fine. Let's see how it is performing. So it's still running. So let me see on the console how much time it's already being spent. So 3 minutes 59 second, and this is still running, and the last job took 5 minutes 21 second, right? with a five hash partition. So this is going to be interesting to see, okay, how much time it taking with the 14. One thing I haven't observed. So I was working on something where we had almost like I don't know, means couple of billion record, and that's where when I have increased this hash partition, I have seen significant improvement in performance. Here I don't see much of improvement, but as I said, like, you have to kind of work with this number to see which one is best suited for your use case. So my job is just to kind of showcase you all those knobs being available within Glue DynamicFrame for you to tweak. And now once you know, you have an option to go and run your job to see which one is running best for you. So we have learned this. Hash partition, and now there are two more knobs being available, which we are going to learn. So this is still running. So that's really strange, because with the 14, it should be running fast, but it's not running. It's not that fast. Okay, so it's 6 minutes done. And this is still running. Let me go and yeah, we'll wait for it to complete. So let me just pause the video for now. We'll wait and we'll come back and see, how much time it took to done. So I'm back. Now I see this job took like 6 minutes, 36 seconds. Um, that's really strange. So yeah, we just learn, right? Even with a higher number of hash partition or number of connections, it's not always like you're going to get best performance, right? So yeah, just try out and see what is the best number for you. So let me go and look into this one here, and if we see, it has added 1, 2, 4, 5 executor. This I don't know why it just added 5 executor. Maybe it's just internally analyze how much executor you need with that many jobs. So here, let's see one thing which I'm kind of wanna see when it's writing. This have anyways, fair enough. So you got an idea, right? So how that will work. So let's go and try out with other knobs here. So the second knob, which let me go back to my presentation here. So we just learn about hash partition. The second will be your second will be your Hashfield. So just think of, like, currently Glue determine which ID it's supposed to be using uh, for uh, for uh, for partition, right? And that happened with the hash field as well. So you will be just kind of setting and giving the column name for which, like, this partition will be happening, and then based on that you will be kind of you will be doing the kind of uh, you will be setting up the column name through which you're looking to make a partition, right? So earlier when we have learned here, so if we look into this query, it's happening based on ID, right? Now once we define hash field here, what I'm looking to do, I will be keeping this hash partition 5, and then I will be going with the hash field sporting event ID. And the reason being I'm going with the sporting event ID, I believe it's a I wanted to have a column where the data is being equally distributed. And when I did a group by with this column, I found, like, okay, it's being well distributed. So, and that's what we need to go with this column. So here are the property. So it can be any data type. It should it can be any data type, so that is fine. That's nice. It can and Glue control the partition, of course, but we were providing the partition column. So that's the three property which we have around the Hashfield. So let's go back and try out, right? So here when I'm trying out, let me go back in my job editor and see here. So this is where I will be having Hashfield. Yeah, perfect. So let me go to the job details. So I have a hash partition 5 because we have learned that 5 is working better. And then we are having that sporting event ID, right? So let's go with the 7. I think that's work best. The 7, I think, as compared to 5. So let's change with the 7, and then we are, instead of ID where it was means it was controlling with an ID, we are just giving a different name. So let's see how the data is being distributed with an event ID. So let me go back to SQL Server, or maybe I can just run the job and then we can go back and look. So this way we are not wasting time. So let me go and run the job. So the job is started. So we'll see how much time it's taking to run. So we'll be starting in any time, right? So startup time is around less than 20 seconds for the glue in most of the cases. So yeah, here, yeah, so it took 17 seconds and now it started. So that's nice. So let's go back and look into the SQL Server and see how the data is being distributed. So select star from, this is my table, all right, sporting event ticket. That's the table name, I believe. Yeah, that's the table name. So, and group by sporting event ticket. So these are the columns. So we are looking to column with the sporting event ID, right? So group by sporting event ID, and then once we're done with it, we will be having, right, so putting if you see here, we got an idea. So this is how the data is being distributed with this this one. So let's see how the query look like. So if I just go and run this 56 and get the SQL. So we got the SQL. Now we're looking to compare how it is different from other SQL, right? So if I just go at the end, so here yes, so this is the different, so if you see here, everything is same how we have with other. The only is now we have this sporting event ID. Everything is remains same. So now this partition is, instead of ID, we are happening with the event ID. Let's see if the count is different with this one. Count will remain same because at the end it's 7, but it's just more like now we are having the partitioning on this column instead of on the so one thing, if I just go and run this here, and if I just go and run this here, keeping everything same, and change this to 3, change this to 7, and run this query. So this is the previous one, and let me open a new query window. So let me close this one. And this is the one which is currently running, right? So let me go and open a new query window. So if I just open a new query window, I got this one. And if I just go and we can go and so this is cluster index, this is happening filters, and this is the parallelism and everything as such, right, with this query. if I just go and generate that estimated execution plan with this one. So again, this is the cluster index scan happening, which is good. You want to have a cluster and cluster index scan. If someone have with a deep SQL knowledge is watching, so my apology, it's been a while. I have worked on SQL Server, so I'm missing lot of good stuff. But I know, like, cluster index is a having scan around the cluster index is it may be the good idea. But my apology if not. So, but again, right, this is how the execution plan is being generated. If I just go and run with an actual execution plan, right, and see how the query is performing, we can get an idea. It means, of course, it has to process lot and data. But anyways, let's see how the job is being. Oh, so my bad. So this job is already being completed, and it took 5 minutes 32 seconds. So let's go back and look into the Spark History Server. Again, at 5 minutes 1 second, not that bad. But again, it's not that good with the one which we had the first time. This goes with the 5 executor, which is fine here as well. And now we have this 7. Okay, so just we got an idea, right? This is fine. Other now the last knob is we call it Hashexpression, right? So again, right, Hashexpression is just also written a whole number like other. The where the important difference is, it's more like, you putting a where clause in order for you to partition your data, right? Or in order for you to create a parallelism against your data. So with Hashexpression and Hashfield. So in Hashfield, you will be giving, like, how the partition is being happened, but is being managed by Glue itself. This is where you will be telling, hey, in terms of where clause, how the partition will happen. So this is different, and it can be only a numeric column, right? So can't be any other column. So let's go and execute with the same configuration and see how that is being happening, right? So let me go back and run my Glue job with that configuration. So here is Hashexpression. So this is my Hashexpression. This looked fine. This is sporting event, and let me quickly validate. I think it was, yeah. So it's a big int. Again, this is fine. So we can easily able to go and run this one here. Once we are running it, we can just simply go and see how this is being performing. We can wait for its start. Let me go back to SQL. I think we ran the query last time. So execution plan. Yeah, I think it's same how we had an estimated execution plan. It has a filter. I don't know, but again, we got an idea, right? How this is happening. This many estimated number of rows being reading, estimated number of rows of read, blah blah blah, CPU, etc. Anyway, so we got an idea. Here we have, so this is for one parallelism. I think for the 7, it's like it will be the 7, but it's of course the operation is it's doing the parallelism. So this is what we wanted to prove, right? How you can enable parallelism against your data set. So nice. So we have proved that part. And again, my apology if you are a SQL guru. I'm not. I'm just trying to understand how that works. So here, I think we ran with the 7, aren't we? So why we have only 5, not 7? But anyways, let me go and run this DBCC input buffer, and this DBCC input buffer is really nice, right? It will give you what kind of a query you are running against a SQL Server. So here it's showing 7, so it's supposed to be 7. I don't know why didn't all those bit was not showing. Maybe not all of them was. Yeah, now we have all of them. So yeah, at the time the connection was making, so it is same. However, when I was working with the MySQL, this query was little different. Here it's showing no change than what we had earlier. However, with the SQL Server, uh, it was little different. I wish I could have that query to show you, but yeah, it was little different than what we have here with the SQL Server. Even I read this part, like, this will work differently for different databases. So last time when I checked with the MySQL, it was way faster when I was increasing the parallelism, all right. And with the SQL Server, I have seen the case is not means even increasing the parallelism and having all these knobs is not giving the expected result. So anyways, I will next time if I try with MySQL, I will try to record that as well. But the whole idea of this video to give you an idea how you can use, or how can you work with the different knobs which is being available for you to tweak your JDBC connection parameter, right? You have a hash partition, you have a hash expression, and you have an Hashfield. So try out with these three parameters, and I think we have really good documentation as well for this in a Glue. You're easily able to Google and find it, or I can add in a video description, right? So that will give you more idea about this parameters. Uh, I will wait for this to complete, and then once done, we will be finishing our video, right? So we can get an idea how the job is being running. And so as of now, it seems like the job with the default configuration ran best, without auto scale, and the second best was having the auto scaling being enabled, right? Or maybe second best was, let me see. So we started here with the default configuration, which was 4 minute. Yeah. The second was auto scaling with the hash partition, where the hash partition was 5. Right, the second best. In terms of cost, this is like running auto scaling with hash partition, where the hash partition is reduced, is best as of now, because it has 4.7, it has 4.3, but here it took like 10 executor. Here I had just had a 5 executor, right? So you can think of like half of the cost to run the query with maybe I don't know, maybe 30-second or 40-second, right? So 30-40 second of difference. Okay, we'll wait for other job to complete. Where is my console? So this is my console, and this job is still running 5 minute 20. Yeah, means it's already past that performance mark which we had for the job. So we know, right, this parameter is this for this particular data set, and this parameter is not helping in that nature. So yeah, it took 5 minutes 51 second. Let me go back and see in here. So yeah, it's a 5 minute 5.3 minute, same, right? So here if I just go and see, so this is how the executor is being added. If I go here, so we have the 7 connection being opened. I see here there's a shuffling is happening, which is fine. I think that is happened with all other as well. So with that, we learn how you can have a you know you can have a how you can optimize your JDBC connection for SQL Server. Sorry, JDB connection for the SQL Server and for MS Glue. Let me quickly show you. So this is the documentation which I was talking earlier, right? So this is the documentation which I have used actually to demonstrate this example. So it has really good read means you can read it this one. And let me find for data frame as well, JDBC parallelism. So as I told you earlier, right? So this is for this is for the dynamic frame, uh, and for the data frame which we have is different. This is the partition column, lower bound and upper bound. This is which you can define for database, right? So yeah, maybe I can make a video around this partition column and lower and these three parameters and see how that is being performing, right? Uh, with that, thank you for watching this one. And as I'm new in my YouTube journey, I will highly encourage you to provide a feedback, and do let me know which next video wanna see. So I work on the analytics of AWS. So I will try to make analytics videos. But if you have if you wanted to learn any other topic on the analytics, do let me know. And if you liked it, do it's really weird to ask, but of course, now I'm making this video, so I should be asking it. Please do like and subscribe and share this video with others. So thank you, and thanks again watching Coffee and Cloud with Navneet. I still have to remember my YouTube channel name is yep. And do provide how you like my channel name as well. Okay. Thank you very much. Take care. Bye.